In this video, we are going to take a look at a bunch of different probability and statistical questions dealing with the kind of the basics of what probability is and the basics of some data analysis ideas. So first here we have to find the probability that rolling a standard dice is going to give you an odd number. Okay. Now in this case, let's say that we are going to roll a standard 12-sided dice. Okay, or a D12 dice. So the first thing that you always want to do is you want to make sure that you create your list that goes along with your dice. So in other words, here we're listing the sides. So when we're talking about a 12-sided dice, we know that you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that is actually the set that we are dealing with. So if we want to know an odd number, then essentially what we're looking at is we are looking at classical probability. So your classical probability is the probability that an event occurs, and that is going to be the number of possible outcomes in your event over the number of outcomes in your sample size. So when we're talking about number of outcomes in your sample, what we're actually talking about here is that this is your total. So for our case, we're dealing with dice. And so what we want to know is we want to know the probability that we're going to roll an odd number. So in looking at our sample, we would count up the number of odd numbers we have. So 1, 2, 3, 4, 5, 6. So we would put the 6 on top, and then we have our total, which is 12 on my dice, so that's 6 over 12. In this case, you would reduce your fraction, gives you 1/2, but you also want to give the decimal. So this is going to be 0.5. This decimal is a finite decimal. It means it ends. Therefore, you would just simply write it as is. Now, if that was a decimal that did not end or had a repeating aspect to it, you would write up to the millionth place of your decimal. Alright, let's look at another one. So here we're going to use the same idea of a 12-sided dice, and in this case we want to find the probability of rolling a number greater than 5. Okay, so again, if we use that 12-sided dice, we again would want to look at what your sample is. So it's the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And you really want to get in the habit of listing out your sample every time you do probability, because that's really going to help you and narrow down your events. So in this case, we are looking at my event being that you are going to roll a number greater than 5. So in this case, if we looked at what those numbers would be, we would be looking specifically at the numbers 6 through 12. So this is actually going to be my event here. So the numbers 6 through 12 are going to tell me what I want. And then my total is still going to be 12. So my event, I have to figure out how many it is. So 1, 2, 3, 4, 5, 6, 7. So there are 7 numbers there. So the probability that I have a number greater than 5 is going to be 7 over my 12. Okay. Now here 7 over 12 is not going to reduce any, so you're going to use your calculator, and in this case you would end up getting 0.583333. Now notice I took this out to the millionth place in probability unless you're told otherwise. That's how many decimals you're going to want to go. And so that's what you would write. So millionth is going to mean 6 places here. Alright, let's look at one more. And so in this one here, we've got the probability of rolling a number less than or equal to 12. So again, we're still using that same sample. And in this case, my event is going to be that I want a number less than or equal to 12. So if I'm looking at my sample, okay, so again, my dice here is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Again, when we're looking at the numbers that fall into my event, all of these values here are less than or equal to 12, so this would actually be the event that I'm looking for. And so because of that, the event that I have a number less than or equal to 12 is going to be the 12 dice. My total here is 12. So the probability that my number is less than or equal to 12 is going to be my 12 from my event, the 12 from my total, which gives you a probability of 1. Okay. Now, this is a whole number, there's no decimal to it, so you would just leave it at 1. But in this case, if we're thinking about probability in terms of percentage, it would be 100% chance that you would have a probability of rolling a number less than or equal to 12. Okay, so that's all the ideas behind classical probability. So let's take a look at another example here. Now here I've got 2 6-sided dice are rolled, and I want to find the probability of rolling the sum of 6. So there's a trick that can be used to make a problem like this a lot easier. And so the way that trick works is we are going to set up a table. So we're going to have numbers across the top, and you're going to have numbers coming down this side. Okay. And so we're going to set this up, and one of the ways I like to do it is I'm looking at, you have, say, dice number 1 going across the top, and we have dice number 2 coming down the side here. And for each of those dice, we had a 6 sides, so the test would be 1, 2, 3, 4, 5, and 6. And then, of course, going down the side would be the same for your second dice here. So we could have, it's 1, 2, 3, 4, 5, and 6. And then what happens is we would fill in the middle your table. And so the way I like to fill it in, very simply, is I like to work down my columns, but of course you could work down the rows. So you choose one. So I'm going to go down my columns. So my first one starts with a 1, so I'm just going to count up in sequential order. So this would be 2, 3, 4, 5, 6, 7. Then I'm going to go to my next one. I start at 2, again sequentially becomes 3, 4, 5, 6, 7, 8, and keep going. 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, and 12. So I have filled in my whole table. Now the reason why I like to do this is because it's very simple here to pick out exactly what I wanted. And so here I want to have the sum being 6. So if you notice inside I have my numbers. So here this would be the sum. So if you think about it, 5 plus 1 gives you 6, and so on and so forth. So here I'm summing to 6. So these right here are the solutions I'm looking for, or all of the possibilities where I would sum to 6. So when I look at that, one of the things that you end up seeing is I have how many that sum to 6. So the way that this works is we're doing the probability that we sum to 6 is given by essentially your sum, or the number that's sum, over we have dice 1 times dice 2. Okay. So in this case, the probability that I sum to 6 is going to be 1, 2, 3, 4, 5. So 5 times will I sum to 6. Dice 1 had 6 sides, so this is 6 times. Dice 2 had 6 sides, so 6. So this ends up being 5 over 36, which is the probability 0.138889. Okay. Now making this table does cut a lot of time out, because sometimes you might be asked to find the probability when you're summing to two different numbers. Okay. So for example, if we were asked to sum to, say, let's say we wanted to find the probability of rolling a sum of 6 and 8. So if we did that, you would circle your 6's, then you would come in here and you would circle your 8's. And so to do that would be very similar. Instead, you would have the probability where you're going to sum to 6 and 8. So in this case, you're going to have sum to 6 plus sum to 8. And then of course it's going to be over your dice 1 times your dice 2. Okay. So doing this little table is very, very helpful in that it gives you a very fast shortcut depending on what it is your problem is asking. Okay. Alright, let's look at this next one. So here we're flipping a coin 25 times. I flipped 18 heads and 7 tails, and I want to know the probability that the next time I flip my coin it's going to land on tails. Okay. So here we're looking for the probability of landing on tails, which is going to be the number of tails, so 7, over my total times flipped so far, so that's 25. Okay. In this case, we would end up with a probability of 0.28 would be the probability of flipping a tails. Now another thing we can do with probability is we can do what's called use the addition rules of probability. So the addition rule says instead of dealing with just one event, now we're dealing with at least 2 outcomes. So we have the probability of drawing a black card or a red. So to do that, there's a few things we need to know. First, you need to remember that in a standard deck, there are 52 cards. Of those cards, you break this down into red, which has 26 cards, and black, which has 26 cards. Now each of these breaks down even further. My red break down into hearts, which has 13 cards, and diamonds, which has 13 cards. And then the same with your black. My black here break down into clubs, which have 13 cards, and spades, which have 13 cards. Okay. Now with that, in a standard deck, the only other thing that you need to know is that of my 52 cards, I am going to have 12 face cards and 40 number cards. Okay, so that's how you break down your deck of cards. Now, with that, we have to look at your probabilities. So here, I want the probability of drawing a black card. So the probability of drawing a black is going to be the number of black cards that I have. So that's going to be 26 out of my possible 52 total. And then I want to know the probability of drawing a red ace. So in each of my red cards, I'm going to have an ace. So I have two different red types. Therefore, I have two chances of drawing an ace out of my 52 total cards. So here, the probability of drawing the black or a red ace, and notice I'm writing my probability event as specific as I can. Well, this is going to be the probability of black plus the probability of the red ace. So in this case, we are going to end up with my probability of black, so 26 over 52, plus the probability of my red ace, 2 over 52. So when we add those together, we are going to end up getting a probability of 28 over 52, which gives us the probability of 0.538462. Now let's do it all again, but in this time we're going to look at a black card or a king. So here the probability of drawing a black is the same as before. I have 26 black cards out of my 52 total. The probability of drawing a king is going to be a little different. Okay. In my king, I have one showing up in all four types because this king is not specified a color. So in this case, it's going to be 4 kings out of my total 52 cards. Well, when doing this, notice I also have to take into account the probability that both occurs. Okay. Now, when I'm talking about both, what I mean is drawing a black king. Because in probability, you cannot count things twice. So the probability of drawing a black king is going to be 2 out of my 52 cards. So the way that this works is that the probability of my event is going to be the probability of drawing a black plus the probability of drawing a king minus the probability of drawing both. And the reason for that is because these events are not mutually exclusive. Okay, case in point, I have 2 black kings, which would fall under both black and king. Since I can't count them twice, I have to remove them. So the probability of drawing a black or a king is going to be my 26 out of 52 plus my 4 out of 52 minus the 2 to represent your duplicates. Now in this case, that just happens to give us a total of 28 out of 52, which from the problem above we know is 0.53846. Now that doesn't always happen. It just happens that in this one the probabilities for these two are the same. Most of the time they end up being something different, so please don't fall into the habit of thinking that if my probability for similar ideas isn't the same, you did it wrong. Okay, you just have to follow the probability for your actual problem. This next one wants to know the probability of not drawing an ace. Okay, so in order to do that, we first have to look at the probability that you did draw an ace. Well, we know that each color or each suit has an ace, so that means there's 4 suits, so there's 4 aces out of my total deck. Okay, so the probability of not drawing an ace is going to simply be your total cards minus the number of aces divided by your total cards. Okay, because in other words, we are looking at how many cards are not aces. So in this case, my total cards was 52 minus the 4 aces in my deck divided by my 52. So here this is going to give me 48 out of my 52, which is a probability of 0.923077. Now another way that we can look at probability is odds. So here in this one, I want to find the odds against rolling a number less than 5. Okay, so in this case, we're going to look at a dice that has 6 sides. So remember, that means we are looking at 1, 2, 3, 4, 5, and 6. And we're looking at odds against. So this right here is the big word that we're looking at, against. So in order to find odds against essentially means you're looking at the probability of your event not occurring over the probability that it does occur. Okay, so I have to figure out what these two probabilities are. So first, I want the probability of my event. So my event is going to be rolling a number. So my event is going to actually be, so A right here, is going to be that I roll a number less than 5. So here this is actually going to be the numbers 1, 2, 3, and 4. So if I count up how many are in my event, I have 4 in my event. Now the probability of not A means essentially I am looking at rolling a number greater than 4. So here this is going to include the sets 5 and 6. So not rolling an A is a 2. Now remember, my dice had 6 sides. So when we're taking a look here at my odds, okay, my odds are going to be the following. Again, we are looking at the probability of not A over the probability of A. So in this case, we would end up with not A being 2 over the probability of A being 4, which we can reduce that fraction down to 1/2. Now, when we write odds, there's a few ways that you can do it. Okay, so writing odds, some things to keep in mind is that your odds can be shown as a fraction. They can be written as number to number, or they can be written as number with your little colon to number. Okay. Now, my personal favorite way to write them would be this middle way. And what we're looking at is the first number here would be your numerator, whereas the second number here is your denominator. So if I have 1/2, then that would tell me that my odds are going to be 1 to 2. And so this would be the method that I would use to answer that problem. Now, odds in favor are going to be the exact opposite. So odds in favor mean, in this case, we're looking at the event on top, whereas not drawing your event is on the bottom. In this case, we're drawing a heart. Okay, so we want the odds in favor. So in order to do that, says the first thing we need to look at is we need to look at the probability of my event A happening. So this right here is going to be that I drew a heart. So the probability of drawing a heart says that I have 13 cards in my deck out of my 52 possible. Now I need to know the probability of not A, which essentially means the probability of drawing a diamond, spade, or club. Okay, so to do that says I have to look at everything that is left. So that means I have 39 cards out of my 52 left. So to find my odds will tell me that it's, again, the probability of A over the probability of not A. So this is going to be 13 out of my 52 over 39 out of my 52. So this reduces or gives me the fraction of 13 over 39. Okay. In this case, I can reduce that down. So this is going to reduce down and give me 1/3. Therefore, my odds are going to be a 1 to 3 chance. And this would be that result. Alright, now what happens if I give you the odds and I want the probability? Okay, so here I've got, based on skills in basketball, a player has odds in favor of making a free throw are 21 to 4. So we're looking at odds in favor, and those are going to be 21 to 4. Now we need to remember the first number is your numerator, whereas the second number is your denominator. And so because of that, that tells us that my odds are going to be the fraction 21 over 4. Okay. Now I want to find the probability that he misses the free throw. So essentially, out of every 100 free throws attempted, how many did he make? Okay. So first of all, I have to look at my probabilities. So here I need to look at the probability that you're going to make it, and I have to look at the probability that you're going to not make it. And those are going to be two different probabilities. Okay, so first I need to find the probability of making it. And so here, when I'm looking at making it, I know that I'm going to have my 21 possibilities, and then on the bottom I've got 21 plus my 4. Okay, so in this case I get 21 over 25, which is 0.84. Okay, and what that comes from is it comes from the formula. Okay, so we have a formula here that we're going to use. The formula that we're looking at is the following. The probability of an event occurring is going to be n over n plus m. Okay, and in this case we know that n is going to come from your numerator and m is going to come from your denominator. Okay, so that is the formula we're using here. So this gives us the probability that he's making it. To find the probability that we're not making it, says you're going to take the probability of 100% chance minus the probability that your event occurred. Okay, again, remembering this event A here was that you make the free throw. So in this case, this would be 1 minus my 0.84, and that's going to give me 0.16. So in this case, what do we know? We know that if he made 84% of the free throws, then out of every 100 free throws, he would make at least 84 of them. All right, let's look more at the multiplication rules of probability. So here I want to find the probability of getting an ace, given that the card you were dealt is a black card. Okay, so here this is going to tell me or make me work with the formula for conditional probability. Conditional is the probability that A occurs given the events of B. So what this means is I'm looking for the probability of A and B given that the probability of B has to occur. Okay, that's essentially what we're doing. So here my first event is going to be the probability of getting an ace. So the probability of getting an ace is 4 out of 52 because I have 4 aces in my deck. Now I want to know the probability that I have an ace given that the card I was dealt was black. So that means my second event is that the probability I have a black card. So in this case, I have 26 black cards to choose from. So here, the probability of getting an ace, given that I was dealt a black, is going to be my 4 out of 52 over my 26 out of 52. So in this case, I'm looking at 4 out of 26, which we can reduce down to being 2 out of 13, but overall gives us a probability of 0.153846. Now the reason why I'm giving you both the fraction and the decimal is because you need to read your directions carefully. Some of your directions are going to ask for the fraction, and some of them are going to ask for a decimal to the millionth place. So you need to know what your directions want. Okay. Now let's look at the probability of drawing a jack, then replacing it and drawing an ace. So what that means is I'm going to draw my jack, I'm then going to put it back, and then I'm going to draw my ace here. So in this case, I need to look at the probability of drawing my jack, which is going to be 4 out of 52. And then I need to look at the probability of drawing an ace, which again is 4 out of 52. Now in this case, since I put it back, what that tells me is I'm looking at the probability of drawing a jack and an ace. Because I put it back, my total doesn't change. So this is my jack times my ace. Okay, so again, we're looking at this one here being the probability of my jack times the probability of my ace. So here you would multiply straight across the top, so this gives you 16, and straight across the bottom, 2704, which gives you a probability of 0.005917. Now these problems are going to be more of permutations. So if I have 8 different desserts on a menu, I want to know how many ways I could list my 3 favorite desserts in order. So the in order part is really important. This means we're doing a permutation. A permutation has a formula NPR, which is going to be n factorial over n minus r factorial. Okay. Now with that, we have to know what's going on. So in this case, we have n being the number of objects, and we have that my r is going to be the number I'm choosing, and in this case my p stands for permutation, which means that order matters. Okay. So in this case, I would just go ahead and plug it in. So the number of objects is going to be my 8 different desserts. So in this case, my n is going to equal 8. The number I'm choosing has to be my 3 favorite, and since the order matters, we're using permutation. So in this case, my r equals 3. So I would plug it in. So I'm going to have 8 permutated 3 is going to be 8 factorial over 8 minus 3 factorial, which in this case is going to be 8 factorial over 5 factorial. Now you can do this by hand without using a calculator, which is to set yourself up to do some canceling. So 8 factorial is going to be 8 times 7 times 6 times 5 factorial all over 5 factorial. In this case, the 5's would cancel, and then 8 times 7 times 6 is going to give me 336 ways. And so this is how many ways that I could choose my 3 favorites out of my desserts. Now this next one, notice it's the same question, but nowhere do we have anything about order mattering. Okay, so in this case we have what's called a combination. So this is the same, it would be NCR, okay, and my formula here is going to be n factorial over r factorial times n minus r factorial. So here again, my n is going to stand for the number of objects. My r is going to be the number that I'm choosing. And my c here stands for combination, which in this case, order does not matter. So we still have 8 desserts to choose from, so my n is going to be 8. And I want to select 3 desserts. My r is 3. So here I would set this up as 8 choose 3. So this is 8 factorial over 3 factorial times 8 minus 3 factorial. So again, in simplifying here, we would have 8 factorial over 3 factorial times 5 factorial. Now, because I have 2 of them on the bottom, just like before, you want to cancel out the biggest one. So this is going to end up being 8 times 7 times 6 times 5 factorial all over 3 times 2 times 1 times 5 factorial. My 5's go away, and this is going to end up with 56 ways. So permutation and combination. Now, a big one that tends to trip a lot of people up is the weighted mean. Now, weighted means are how high schools and colleges calculate your grades. So there's either a 4-point scale or a 5-point scale. So wherever you are, before you start trying to calculate a weighted mean, you need to make sure that you know the weighted scale that's being used. Most schools use a 4-point scale, but some of them use 4.5 or 5. So always double check before you start trying to figure things out. Now with this, the weighted mean, very simply, you have to look at your course hours and your course grade. So the very first thing you need to know is you need to know what your total attempted course hours are. So you need to add those up. Okay? So essentially I have 2 plus 3 plus 4 plus 2 is going to give me 11. Now the next thing you need to do is you have to figure out your grade points. So we're going to do what's called sum your grade points. So we're going to look at each of your grades. And so the way that I like to set it up is very easy. I like to kind of make myself a table. So here I know in general we have A, B, C, D, and F. Okay? And so I'm going to find my sum of those. So I have to look at what I'm doing. Well, to sum the grade points is going to say that you are going to take the number of hours and you're going to multiply that by the points. Okay? So for my A, if I look here, the number of attempted hours was 4. So I have 4 attempted hours. The number of points I earned is 4 points. So this is going to give me 16 total. Now B's are next. So here B's, I had 2 attempted hours. So 2 attempted hours at 3 points each. So 2 times 3 gives me 6. For C's, I had 2 hours and I earned 2 points. So this would be my 2 attempted hours times my 2 points gives me 4. For D's, I had 3 attempted hours at 1 point each. So 3 hours at 1 point is going to give me 3. And F's, I had no F's and you earn 0 points, so that's 0. So I'm going to add up all of these numbers here. Okay? So the numbers that are the most important are the ones that I'm going to add. So it's going to be these numbers right here that I'm going to all add together. Okay. Let me try that again here. So again, these ones are the ones that we are looking at, this column. So when we add all of those together, we're going to come out with 29. Okay. Now that number is important because in order to find your weighted mean or your weighted GPA, you are going to take the sum of your grade points and divide that by the hours attempted. So in this case, the sum of my grade points was 29. The number of hours attempted was 11. So here this is going to give me 2.636. All of our grades are generally given to the nearest tenth. So we would look at this as having a GPA of 2.6. And this would be the result that you were looking for. Right, now the very last thing that I wanted to look at real quick has to do with a normal deviation. So let's go ahead and do that real quickly here. When you're creating a normal deviation curve, what's really important is to fill out your curve with your information. So first things first is to fill out your lines. So here in the middle is going to be your mean, and then you're going to have 1 standard, 2 standards, 3 standards. So we're going to add, and then on the other side we're going to subtract. So then minus a standard, minus 2 standards, minus 3 standards. Okay. Now it's important to figure all of these out. So here I'm going to drop my dotted lines really quickly. Okay, so we've broken it down into its sections. So when we're working with our sections, we have to kind of know how they're supposed to be broken apart. Okay, so first and foremost, you have your mean in the middle, and we know my mean right here is 70. So right at the top, this is going to be my 70. Now, between my first standards, so from here to here, is going to represent my first batch. So this is going to be 68% of all my grades. Now that being said, in between my single standards, so from -1 to my mean or mean to 1, this is looking at 34% of the grade. So it's important to know how each of them is broken down. Now we have two standards. So my two standards goes obviously from there to here, and my two standards is represented by 95% of the grade. So we already know these two middle chunks here to be 34%, but if I look at from my second standard to my first, here we are actually looking at 13.5% of your grade, and it would be the same over in this side. This side over here would also be the 13.5%. Okay, and again, that's the same. This right here would represent your 34%. Now the last thing we have is my third standard, so we would go from here all the way over to my third here, and this represents 99.7% of the grade. Between my third and second standards, so this one here to here, is going to be represented by 2.35%, and it's the same on the other side. So this between here and here is that 2.35. And then of course you have the last. So from there over is representative of 0.15%, and the same from here on is 0.15%. Now that being said, we have to fill in our numbers. So if this is our mean, which is 70, to go to my first says I have a standard deviation of 5. So this would end up being 70 plus 5, which gives you 75 as my second. We would then take to go to my, or sorry, as my first. My second would be the 75 plus 5, which is going to give you 80. To get to my third is going to be 80 plus 5, which gives you 85. You need to subtract. So here my negative first would be 70 minus 5, which is 65. We would have 65 minus 5, which is 60. And then we would have 60 minus 5, which gives you 55. So you need to set everything up before you try and answer questions. Once you have your normal distribution all set, then you can answer the question. So the first one says, what percent of scores are between 65 and 75? So we have 65 and 75 here, so this is going to fall between my -1 and +1 standard. So this is very simply 68%. That's all we're looking for. Here, what percent of scores are between 60 and 85? So 60 is right here at my -2. We're going to come all the way to 85, which is at 3. So we have to look at what it is we're all trying to add together, and we would go ahead and do that. So here we would have from -2 to 2 is going to be 95%, plus we still have to get 2.35, so we're adding another 2.35%. It's going to give me a total of 97.35% of the scores. What percent of scores are greater than 80? So we come over here and look, here's my 80. So here we would have from 2 to 3 and then 3 and beyond. Okay, so this here is going to be 2.35% plus 0.15% gives me a total of 2.50% of the scores. And then last, I want to know approximately how many students score between 60 and 70. Okay, so first I know that there are 2,000 freshmen here, and I'm looking between 60 and 70. So here is 60, up here is 70, so we're looking at -2 all the way over to my mean. So from -2 to 1 is 13.5. So this is going to be my 2,000 students times 13.5% plus, and then I have to go from -1 to my mean, which is 34. So 13.5% plus 34%. So here this is going to be 2,000 times 47.5%. 47.5% is a decimal. Remember, divide by 100, so this is the same as 0.475. So you would do 2,000 times 0.475, and that is going to give you 950 students. Okay. And that's really all you have to do to it. So there are your normal distribution. Okay. And everything you would need in order to get started with the basics of probability and some data analysis. So if you have any questions, I know this is a lot of information, please let me know. Otherwise, I wish you the best of luck, and I'll see you next time.